Hi, the topic of this video is determinants. Now, determinants is a topic that you should have covered in previous calculus courses or in your linear algebra course, but since we're going to be using determinants quite a lot in this course, I think it's a good idea to review determinants. So I'm going to show you how to compute 2 by 2 determinant of a 2 by 2 matrix and determinant of a 3 by 3 matrix, and what do they actually represent. So, given a 2 by 2 matrix A, B, C, D, the determinant of this matrix, and the way the notation works is that we have two lines, A, B, is equal to AD minus BC, A times D minus B times C. Alright. So let's have an example. Given the matrix, I want to compute the determinant of this matrix over here, 4, 6, 3, 8 is equal to 4 times 8 minus 3 times 6, which is going to be 32 minus 18, which gives us 14. And that is the determinant of this matrix. Now, what does the determinant of a matrix represent? Well, let's see. Given two vectors, vector v with the components a, b, vector u with the components c, d. If you draw these vectors, let's call this v, let's call this u. These two vectors over here define a parallelogram. So if you draw extension lines, they create a parallelogram. And the determinant of this matrix created by these two vectors is going to give you a number. Let's call it x. Then the absolute value of this number is going to be the area of the parallelogram. Okay. Alright. Now, 3 by 3 matrices. Let's say I want to compute the determinant of this matrix, A, B, C, D, E, F, G, H, I. Now for 3 by 3 matrices or even larger matrices, you need to know the sign of the entries. It starts with positive, negative, and you keep on going. Positive, negative, and you keep on going. So this is negative, this is positive, and so on. So you pick either a row or a column. Usually we pick rows or columns with zeros in them because it makes calculations way easier. So for this explanation here, I'm just gonna pick the first row. Then you pick the first entry, which is gonna be A, and A has a positive sign. You hide the row of this entry, the column of this entry, and you multiply A by the determinant of this matrix, E, F, H, I. Okay, then you move to the second entry, which is going to be B, and B has a negative sign. Then you hide the row of this entry, the column of this entry, and you find the determinant of this matrix, which is D, F, G, I. Then you go to the last entry in the row you picked, which is going to be C with the positive sign. You hide the row of the entry, the column of the entry, end up with D, E, G, and H. And after you do this whole computation, you get the determinant of this matrix. Alright, let's have an example. I want to compute the determinant of the matrix 1, 2, 1, 3, 0, 4, 8, 4, 10. Let's go by rows, or actually let's go by columns. Since I did the last example here by rows, let's go by columns. So I look for columns and I'm gonna pick the second column because it's the column that has most number of zeros. And again, why do we pick the columns or the rows with most number of zeros? Just because it makes the calculations easier. If you decide to pick a different row or a different column, you should get eventually the same answer. Okay, Now remember, the sign of entries is positive, negative, and so on. Positive, negative, and so on. So for this column over here, since this is positive, this is going to be negative, and then negative, positive, negative. So it's going to be -2. Then I hide the row of the entry, the column of the entry, and I end up with the matrix 3, 4, 8, 10. Alright, move to the second entry of the column I picked, which is going to be 0, so it's plus 0 times the determinant of, and it doesn't really matter at this point what's the matrix in there, because 0 times anything is going to be 0. Alright, so I move on to the third entry, which is going to be 4, and 4 is going to have, well, this is negative, positive, negative, so it's going to be -4. You hide the row of the entry, the column of the entry, and you end up with 1, 1, 3, 4. So let's do the computation. You get -2 times the determinant of this matrix, which is going to be 30 minus 24 plus 0 minus 4 times 1 times 4, which is 4, minus 1 times 3, which is 3. So you get -2 times, I'm sorry, this should be 32, because 30 minus 4 times 8, which is 32. Okay, so it's -2 times -2 plus 0 minus 4 times 4 minus 3 is just 1. You get 4 plus 0 minus 4, which eventually gives you 0. And that's the determinant of this matrix. Now if you wanna try, I actually encourage you to try pick a different row or pick a different column, compute the determinant. You should eventually get 0 as the determinant of this matrix. Alright, so what does the determinant of a 3 by 3 matrix represent? Let's say you're given 3 vectors, v1, which has the components a, b, and c, v2, which has the components d, e, and f, v3, which have the components g, h, and I. These 3 vectors over here define a parallelepiped. In case you don't know what a parallelepiped is, think of it this way. In 2D, in 3D, okay. In 2D, if you have a square, in 3D it becomes a cube. In 2D, if you have a parallelogram, in 3D you have a parallelepiped. So if you have a parallelogram in 2D, in 3D it becomes a parallelepiped. Well, I'll draw it in a second. So these 3 vectors define a parallelepiped. So if you draw the extension lines, and this is your parallelepiped. Now the determinant of the matrix created by these 3 vectors, a, b, c, d, e, f, g, h, I, it's gonna give you a number, let's call it x, and then the absolute value of the number x is gonna be the volume of the parallelepiped. Alright, so that's all I want to talk about regarding determinants. As usual, if you have any questions, leave them down in the comment section below, and I'll be more than happy to answer them. Good luck.